we're going to how XOR gate and XNOR gates can be used from logic gates. Yeah, that's what we're going to talk. So let's start with that. So we know for XOR gate, we have the truth table. Okay? So let's talk about that. So the truth table, you have A and B, the output Q, that is A XOR B, reflected 0, 1, 0, 1, 0, 1. And the output will be 0, 1, 1, 0. Okay. So this is the normal XOR gate. Okay. And we know it is drawn like this. Have a small curve in front of the OR gate, and that will be the XOR gate. So this is A, this is B. The output Q can be given as A XOR B. Okay. So what actually happens inside XOR gate is, okay, actually we are using, OR gates and AND gates to replicate this behavior. Okay. OR gates and AND gates to replicate the behavior. So what is going on here? So let's draw the inputs first of all, input lines. So we have the line for A, we have the line for B. Yes. So this is A and this is B. Okay. So what happens is, first of all, we pass A through a NOT gate. Okay. We pass A through a NOT gate. Okay. We pass A through a NOT gate. And we have B taken, and these two, okay, these two are passed through an AND gate. Okay. They are passed through an AND. Okay. Similarly, B is passed through a NOT gate, and then A is also passed through along with the B bar through AND gate. So here you have A bar, here you have B. So the output will be A bar B. Okay, A bar B, or you can say A bar dot B. Okay, and then here you have A dot B bar. Why is that? Here you have B bar, here you have A. So after this, what we do is we pass it through. Okay, we pass it through an OR gate. Okay, we pass it through an OR gate. Okay, so here the output will be, actually the output, let's say this is the Q. The Q output will be given as A bar dot B plus A dot B bar. Okay, so this will be the output. This is actually what we mean by XOR function. Okay, XOR logical function. This is what actually happens when we are performing XOR function. Okay, this is one way of representing XOR. Okay, this is one way of representing XOR. Why am I doing this? I'm just making you familiar with how you can draw circuits for a given gate. Okay, so we have already talked about NAND gates, NOR gates. We have talked about them. So, and how multiple inputs can work for them. Yeah. Similarly, this is what happens. Okay. Similarly, for XOR gate, inside XOR gate, the structure is somewhat like this. Okay. The structure is somewhat like this. Okay. And for XNOR gate, obviously we know we just have to put a NOT gate in front of it. Okay. But there is also another way to actually draw XNOR gate. There is also another way to draw XNOR gate. First of all, let's refresh our memory. So we have XNOR gate. If you have two inputs, okay, hereafter I won't draw the lines and all because it's not required actually, because we know what we are doing. But if you want to draw and make a neat work, obviously go for it. I am all for neat work. But here it's not actually required, okay, because we know what we are talking about. A and B. So this will be XNOR, right? A XOR B, whole thing bar. Okay. So let's say we have 0, 0, 1, 1, 0, 1, 0, 1. The output will be 1, 0, 0, 1. So this is what we have for XNOR. And this looks like this. The diagram will look like this. Here you have the XOR gate, and you just have to draw a simple circle in front of it to mention that it is a XOR gate. Okay, so the output Q can be given as A XOR B whole thing bar. Okay. Actually, this can be represented in another way. It can be represented in another way. How do we do that? Well, it's also pretty simple. Let me draw the input lines. So here we have the line for A, here we have the line for B. Okay. First of all, what we do is we just pass through A and B through an AND gate. Okay. We pass through A and B through an AND gate. Okay. So this two are passed together. So here you have A, here you have B. So the output will be A dot B. Then what you have to do is you have to pass A through a NOT gate, okay, as well as B through a NOT. You have to pass through A through a NOT gate and B through a NOT gate, and then we have to pass them through an AND gate. Okay, so here you have A, here you have B, but when they are passed through a NOT gate, it becomes A bar, and this becomes B bar, and the output will be A bar dot B bar. Then finally, we will pass them through an OR gate as we usually do. A, so this will be A XOR B whole thing. Okay, so what is the actual output that we are coming up with? Well, that is A bar B bar. Let's say Q is the output. A bar B bar. So I'll just use the dot. Okay. So Q is equals to A bar dot B bar plus A B, and this is exactly equals to A XOR B whole thing bar, or you can say A XNOR B. Okay, so this is the idea behind XOR and XNOR gates. Okay, now you know how to build them using basic logic gates. Now what we are going to do is how multiple inputs can be passed through XOR gate. That's what we are going to learn. So let's start with three inputs. Actually, in three inputs, the thing is, this thing is, it's a little bit different from how two inputs are given to a specific XOR gate. So first of all, let's draw it. So let's say we have an XOR gate, okay, and you're passing through three inputs. Okay, so 1, 2, and 3. So here we have A, here we have B, here we have C. The output can be given as, let's say that is Q, that can be given as A XOR B XOR C. Okay, so when I taught you the two inputs thing, I said if either outputs are different, okay, if A is 1 and B is 0, or A is 0 and B is 1, the output will be 1. Well, when it comes to three inputs, how you can easily understand this is if odd number of inputs are 1, okay, if odd number of inputs are 1, then the output will be 1. Okay, if odd number of inputs are 1, well, then the output will be 1. So let's talk about the truth table here. So we have A, we have B, we have C. So A XOR B XOR C can be given as actually A XOR B, A XOR C. Okay, so how I can break this down is, let's say we have A line here, B line here, and C line here. Okay, so this is A, this is B, and this is C. So what we do is, first of all, we pass A and B through a single XOR gate. Okay, we pass A and B through a single XOR gate. Okay, I'm not gonna waste my time on drawing the basic gates here, because we know what's happening inside this, right? So that's enough. Now we have passing that through. Okay, after A and B are passed through an XOR gate, the output will be A XOR B. Okay, then A XOR B and then C will be passed through another XOR gate. Okay, so here the output will be A XOR B XOR C. Okay, so which is equivalent to actually A XOR B XOR C. Okay, so first of all, let's find A XOR B. Okay, then we can find the final output A XOR B XOR C. Okay, when we do like this, okay, when you break down the expression smaller and smaller, it becomes easy for you to do the question. So here we have three inputs, which means we have how many combinations? 8 combinations. Very good. So 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, and then 0, 0, 0, 0, 1, 1, 1, 1. Okay, so these are the combinations. So A XOR B, we know, right? If both inputs are same, the output is 0. So this is 0, this is 0, but this is 1, this is 1. Why? 0 and 1, 0 and 1. Then we have 1 and 0, which means 1, 1 and 0, which means 1, 1 and 1 means 0, 1 and 1 means 0. Okay, now we have A XOR B and C. Okay, from these two, you will check if you have the same input or different inputs. So we have 0 and 0, so it will be 0. Different inputs, so 1. Different inputs, so 1. Same input, so 0. Different inputs, 1. Same inputs, 0. Same inputs, 0. Different inputs, 1. Okay, so here it's a little bit different than what we did with the two variables. Okay, so that's why I said when you have 3 inputs, okay, and you have to find out the output of the XOR of A, XOR B, XOR C, well then check if the odd number of inputs are equals to 1. Okay, again, it's the same thing. Only one input can be 1. Okay, so if you see here, I'll underline the important parts. So this is 1, this is 1, this is 1, and this is 1. Okay, so if you underline those combinations, you can clearly see only one of them, okay, only one of them is 1. I mean, yeah, other than the last one. There are 3 inputs are 1, which is also an odd number. Okay, which is also an odd number. So this is how you can pass multiple inputs through an XOR gate. Okay, so this is the same for XNOR gate also, but the outputs will be reversed. That's all. Why? Since this is XOR, we have A XOR B XOR C. For XNOR, we will have A XOR B XOR C whole thing bar. Okay, that's the only difference. Okay, and there will be a circle in front of it. Yeah, but other than that, it's the same idea. So what I want you to do is, on your own time, okay, on your own time, try for XNOR like this. Draw a diagram by using XOR gates and then the NOT gate, okay, and then draw the truth table by yourself. The more you do these things, okay, the less familiar they become. Okay, the less familiar they become. And I think repetition is very important when you're learning something like this. So we will be doing some practice questions in the next video. So stay tuned.
Thanks for watching the 4th video in our Logic Gates series. If you found this deep dive into XOR and XNOR gates along with their behavior with multiple inputs helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master Logic Gates and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.